So here the problem is a series RLC circuit has R equal to 10 ohms, L equal to 0.5 Henry and C equal to 40 microfarad. The applied voltage is 100 volt. Find resonant frequency, upper and lower half power frequencies, quality factor of a coil, bandwidth, current at resonance, current at half power points, voltage across inductance at resonance, impedance. So very important problem. So here a series RLC circuit. So resistance, inductance and capacitance are connected in series. R value is given as 10 ohms, L value is given as 0.5 Henry and C value is given as 40 microfarad, and all the three elements are connected in series. And the series circuit is connected to the voltage, so 100 volts. So the applied voltage is 100 volts AC. So here we are asked to find resonant frequency, upper and lower half power frequencies, quality factor of a coil, bandwidth, current at resonance, current at half power points, voltage across inductance at resonance, impedance. Now let us draw the diagrams first. So resistance, inductance and capacitance connected in series, and the combination is connected to a voltage source, here V. And once you connect the circuit to the voltage source, there is a current in the circuit, let it be I. And here it is a resonance problem, so means we have to draw the diagram. On x-axis is frequency. So here I am taking y-axis, in y-axis I am taking current. So if you draw the current waveform, current in the circuit against frequency, so current looks like this. So here Fr is the resonance frequency, F1 is F1 and F2 are the cutoff frequencies. F1 is lower cutoff frequency, F2 is higher cutoff frequency, and at resonance frequency maximum current flows in the circuit, and that maximum is Im. And at cutoff frequencies, current in the circuit is Im by root 2, 1 by root 2 times of the maximum current in the circuit. So first question is, so here resonant frequency. So here first question we are asked to find the resonant frequency. So formula to find the resonant frequency is, so resonant frequency, formula to find resonant frequency is Fr equal to 1 by 2 pi root LC. So if you know the values of inductance and capacitance, we can find the frequency at which the circuit is resonance. So 1 by 2 pi root LC. So LC values are given in the problem. So that is 0.5 Henry is the inductance value, and capacitance value is 40 microfarad. If you substitute the values, so you get 35.6 Hz. So that is the resonant frequency. So if you want resonance frequency in radians per second, so multiply that Fr with 2 pi. So we get the frequency in radians per second. So relation between omega r and Fr is omega r equal to 2 pi Fr. So 2 pi into 35.6, so which is equals to 223 radians per second. So this is about a resonant frequency. So and the second question is, so here second question is quality factor of a coil. So coil means resistance, coil can be replaced with resistance and inductance connected in series. So quality factor of a coil is equals to at resonance omega r L by R, that is XL by R is the formula to find quality factor of a coil. So XL is equals to reactance offered by the inductor. So we can replace that with omega r L. So where omega r is the resonance frequency in radians per second, L is the inductance value and R is the resistance value. So if you substitute the values omega r, L and R, so we get 223 into 0.5 by 10, which is equals to 11.15 is the quality factor of a coil. Next, so to find lower half power frequencies, so in radians per second, so that is omega 1, so lower half power frequency, So we can indicate lower half power frequency with omega 1. So to find the omega 1 formula is so minus r by 2l plus root r by 2l whole square plus omega r square. So if we substitute the values of r, l and omega r in this expression, we get minus 10 plus 223, which is equals to omega 1 is equals to 213 radians per second. So in terms of hertz, f1 equal to, that is lower cutoff frequency in terms of hertz, omega 1 by 2 pi, so which is equals to 34 hertz. So similarly, upper half power frequency, so which is indicated with omega 2. So formula to find upper half power frequency is omega 2 equal to r by 2l plus root r by 2l whole square plus omega r square. So if you substitute the values of r, l and omega r in this expression, we get 10 plus 223, so which is equals to 233 radians per second. So that is a upper half power frequency in radians per second. So if you want these values, equivalent value in hertz, so f2 equal to omega 2 by 2 pi, which is equals to 37 hertz. So next is bandwidth. So bandwidth, to find bandwidth, so similarly here we can find bandwidth in radians per second as well as in hertz. So in radians per second, bandwidth is equals to omega 2 minus omega 1. So if you know the half power frequencies, so the difference of half power frequency is nothing but bandwidth. So omega 2 minus omega 1, which is equals to 20 radians per second. So similarly, if you want bandwidth in hertz, so take the difference of half power frequencies in hertz, f2 minus f1, which is equals to 3 hertz. So similarly, next question is current at resonance. So when the circuit is under resonance, so what is the current in the circuit? So maximum current will flow in the circuit. So V equal to R into Im. So where R is the resistance, Im is the maximum current flowing in the circuit. So at resonance, Im maximum current is flowing in the circuit, and impedance offered by the circuit is resistance itself. So the relation between V, R and Im is at resonance V equal to, where V is the supply voltage, V equal to R Im. So from this Im equal to V by R. So V is given as 100 volts and the resistance in the circuit is 10 ohms. So maximum current flowing in the circuit at resonance is 10 amperes. So current at resonance is 10 amperes. So next we are asked to find current at half power points. So current at half power points. So from the diagram, so current at cutoff frequencies is Im by root 2, 1 by root 2 times of the maximum current. So if you substitute Im as 10, 10 by root 2 is 7.07 amperes. So at cutoff frequencies, current in the circuit is 7.07 amperes. At resonance, current in the circuit is 10 amperes. So and last question is voltage across inductance at resonance. So what is the voltage across the inductance at resonance? So in general, current in the voltage across the inductance is equals to current into the reactance offered by the inductor, I into XL. So but what is the current in the circuit at resonance? Maximum current is flowing, that is Im, and XL is equals to omega L, but at resonance omega is omega R L. So VL is equals to 10, maximum current is flowing in the circuit 10, and omega R at resonance is 223 radians per second, and inductor value is 0.5 Henry. So which is equals to 1115 volts. So that is a voltage across the inductance at resonance. So voltage is more than the supply voltage. So here it is voltage is magnified. So VL is equals to, so we can check this value, we can verify this value in another way. So VL is equals to quality factor times the supply voltage. So quality factor is 11.15 into voltage, supply voltage is 100. So product of quality factor at resonance into supply voltage equal to voltage across the inductance. So which is equals to 1115 volts. So we can verify this value with this VL. So which we got by using I into Excel. So very important problem.